So you guys try this. F of x is equal to negative 3x squared plus 12x minus 7. And I just want you to write this in vertex form. Who needs another minute? Anybody need another minute? We all got it? Okay, could somebody tell me, what did you get? Charlie.
Negative 3 times x minus 2 squared plus 5.
I got the same. Does anybody need to see how we got this? Okay, so first question for you. Will this be a maximum or minimum, and how do you know? Good, how'd you know? Good, because our A is negative, we know this is going to be a maximum, meaning it's going to be frowning. We'll have a highest point. How come we don't have a lowest point? Yeah, because when you're frowning, you're going down forever, right? So we have our highest point, but we don't have the lowest point. All right, next question for you. What is the vertex of this parabola? Ariana, you got it. And what would be the maximum here? Since we said this was a maximum, what would be the maximum? What is Violet? You got it. The 5 is our max. Okay, so now we're going to take this whole idea of maximum, minimum, we're going to bring it into word problems. So the first one is going to say the sum of two numbers is 24. Find the two numbers if their product is to be a maximum. Okay, because we're going to be allowed to use Desmos, the hardest part here is just going to make the equation that we're going to plug into Desmos. So it says the sum of two numbers is 24. I don't want to make this a system of equations. I'm not trying to use x as one number, y as the other number. I'm not trying to do that. So if I want to keep the two numbers both in terms of x, how would I do this? Well, if the first number is x, And now they're saying their sum is 24. Like I said, I don't want to use y to represent the two different numbers. So I can't say x plus y equals 24. But if one number is x and they have to add to equal 24, how can I represent the second number? Anushka? You got it, 24 minus x. So my first number is x, my second number is 24 minus x. And if I were to add x plus 24 minus x, isn't that sum 24? So we're good there. So now it says find the two numbers if their product is to be a maximum. This is where we're going to make our equation. So I'm going to say f of x, or you could use y, it doesn't matter, because this is what I'm going to plug in to Desmos. F of x or y, does not matter which one you're using, is going to equal the product. So I'm going to have x times 24 minus x. I don't need to multiply this out, but if I were to distribute this in, wouldn't this be a negative x squared? And because it's a negative x squared, well, we know it's a parabola because it's x squared, right? And because it's negative x squared, isn't this going to be a frown? So won't it have a maximum point? So now all we have to do, once we come up with the equation, now all we have to do is go into Desmos. You don't have to put it in vertex form. You don't have to do any of that. So let's go into Desmos. Yeah, you guys want to use Desmos to practice. If you don't want to take out your Chromebook, that's okay. You could just watch. It's not a problem. And I'm going to put my equation f of x. If you had written y, would it be okay to write y equals instead of f of x equals? Yeah, it's the same thing. They're interchangeable. So f of x equals x times 24 minus x. Did it work? Should work. There we go. Yep. And I'm zooming out so we could see our maximum. Okay. So our maximum here is 144. I wasn't asking for that maximum. That 144 represents f of x. That's our maximum. But I want the x coordinate here. What's the x coordinate? 12. So now what we're going to do as per Desmos, we know that the max is 144. It didn't ask for that. I'm just writing it down. When x is equal to 12. So max is 144 when, put it here, x equals 12. So what does that mean? It means my first number is 12, and the second number, just by coincidence, ends up being also 12, because 24 minus 12 is also 12. Ready for the next one? Okay, so I want to find two numbers whose difference is 48 and whose product is a minimum. Okay, so find two numbers whose difference is 48. Again, am I going to accept a system here? Can I let one number be x, the other number be y? No, I want both numbers in terms of x. So we want to find two numbers whose difference is 48, but whose product is a minimum. So right now I'm going to let first number equal x. And now when I have my first number and my second number and I multiply them, do I want a positive x squared or do I want a negative x squared? We want a positive. Why? How do I know when I multiply my first number and second number that I'm going to want a positive x squared? Ariana? Because it's a minimum, meaning I need a smile and I need a minimum point. So that means our A has to be positive, right? So now if my A has to be positive, am I going to write 48 minus X? No, wouldn't that create a negative? I can't have a negative when I distribute, but I do know whose difference to be 48. Well, think about it. If I have x plus 48, this makes more sense, right? So if my first number is x and my second number is x plus 48 and I subtract them, wouldn't the x's cancel and I'll just be left with 48? Assuming my second number is bigger, right? Okay, so now I have my two numbers and it says whose product is a minimum. So now I'm going to say y is going to equal x times the quantity of x plus 48. Do I need to multiply this? Do I need to put it in vertex form? Do I need to do any of that? No, I'm going to go right into Desmos. I'm going to type it in. So last time I used f of x, this time I'm using y equals, it's going to still work out, x times the quantity of x plus 4. And I have my minimum. Let's say I came up with something and it ended up being a maximum. What would that tell you? Something went wrong, right? Yes. Oh, plus 48. It is supposed to be plus 48. Thank you. And there's my minimum. All right, so now let's go to that vertex point. What does the negative 576 represent? The minimum. Do I want that number? No, I want the x coordinate that goes with that minimum. What's the x coordinate that goes with that minimum? Negative 24, you got it. So we're going to have our first number is negative 24. So now our second number is going to be negative 24 plus 48. So our second number will be a positive 24. Yes.
So couldn't you just do a negative b over 2a? Or does that have like a difference?
Negative b over 2a to do what?
So like, yeah, negative 24.
That would work, yeah.
Okay.
I just didn't show you guys that, but if you know that, you could use that. All right, let's keep going. Okay, suppose that 60 meters of fencing is available to enclose a rectangular garden. one side will be against the side of the house. What dimensions of the garden will guarantee a max area? Is everybody done copying? Anybody need another minute to copy down? Okay, so let's think about this. Let's get a diagram going as well. It says, suppose that 60 meters of fencing is available to enclose a rectangular garden. Right? What is that 60 meters going to be used for in terms of that rectangle? That 60 meters is going to represent its what? People every time? Anybody else? Really? The perimeter, exactly. But one side is against the house. So will we need the fencing to cover the side that's against the house? No. So here is our house. That side we don't need fencing for. We just need it for the other sides. So we need to make that 60 meters of fencing cover this side, and this side. So cover the three sides. But because it's a rectangle, think back to geometry. Don't we know that the left and the right are congruent? So if this is X, it's in a rectangle, opposite sides are congruent, then this is also X. Do we agree? So now if this is X, and and we have 60 meters all together, how much would be left for that bottom side? 60 minus 2x. You got it. So this is 60 minus 2x. Okay, let's keep going now. So it says, suppose that 60 meters of fencing is available to enclose a rectangular garden. One side will be against the side of the house. So we got our diagram. What dimensions of the garden will guarantee a max area? Well, do we agree this garden is a rectangle? And how do we find the area of a rectangle? How do we find the area of a rectangle? Leo? Length times width or base times height. You got it. All right, so we're going to have the area is equal to base times height. Now, when we're finding the area, does it matter that it's up against the house for that part? No. So it's still just going to say stay base times height. So our area in terms of x, so I'm going to say a sub x, or sorry, a of x, not sub x, a of x is going to be x times 60 minus 2x. And you could write the quantity of 60 minus 2x times x. Multiplication's commutative. It doesn't matter. Do I need to distribute in? No. Do I need to find vertex form? No. So let's go into Desmos and just type this in. We're going to have a of x is equal to x times the quantity of 60 minus x. So I'm going to zoom out to try to find where my vertex is. So I'm up here. I go to my vertex, and now we have the point, my vertex point is 30, 900. Now I'm asking what is the, something go wrong here?
So,
I did something wrong. Yeah, there we go. Like something was missing here. 2x, 60 minus 2x. There we go. That looks better. Dimensions didn't look right. Let's look here. All right, much better. So here I want to know what dimensions of the garden will guarantee a max area. Well, what is the max area, first of all? What's the max area, Amanda? 450 meters squared, right? Square meters. That is our max area. That's the biggest area we can have in that enclosed space. If I was asking for the max area, we could just say 450 meters squared, but I wasn't asking for the max area. I said, what would be the dimensions that would create the max area? So go back here. The max area gives us an x of 15. So if the max area gives us an x of 15, the dimensions were x and 60 minus 2x. So x will equal, what did we just say that was? 15? And then we're going to have 60 minus 30, which is 30. So our max dimensions is going to be a 15 by 30 or 30 by 15, however you want to write it. Meters. All right, we are done for today. So you can get started on your homework.